In this video we are going to see how to solve systems of equations with 2 variables and 3 variables by using Cramer's rule. So in this question we are given a system of equations with 2 variables. First, let's write our coefficient matrix, which is 2, 3, 5 and 6. Now, the idea is as follows. We are going to calculate x and y by using determinants. We will have a fraction of determinants, which at the bottom we will always have the determinant of the coefficient matrix. Now this is the same for while we're calculating y. So we will have the same determinant of the coefficient matrix. Now at the top, for x I'm going to write a determinant changing the first row with the results of the equations, and the second column will be the same. For y, I'm going to write a determinant here which the second column will be the results, 4 and 5. The first column will be the same as the coefficient matrix. So, for x, I change the first column with the results. For y, I change the second column with the results. Then I'm going to calculate those determinants. So it will be 4 times 6, 24, minus 5 times 3, 15, divided by 2 times 6, 12, minus 5 times 3, 15. So it will be 9 over minus 3, which is minus 3. And for y, it will be 10 minus 20, and 12 minus 15, it will be the same as x because it's the same determinant. So we'll have minus 10 divided by minus 3, which is 10 over 3. So what if we have a 3 by 3 system? Well, the idea is the same. I'm going to write a coefficient matrix again. So it will be 1, 1, 1, 6, minus 2, minus 1, and 3, 4, 2. This is my coefficient matrix. Now, for x, I'm going to write again 2 determinants. The bottom will be the determinant for the coefficient matrix. So, the top will be the determinant which I change the first column with the results. And how I'm going to calculate is as follows. I will write the elements in the first row to be the coefficients, and I'm going to calculate the remaining 2 by 2 determinants as follows. So it will be 12 times this determinant and minus 1 times this determinant plus 1 times this determinant. So the idea is the same for the determinant at the bottom. 1 times this matrix minus 1 times this matrix plus 1 times this matrix. Now we can calculate the determinants of 2 by 2. So it is 12 times minus 4 minus minus 4 for the first one, minus 1 times 32 minus minus 28, and for the last one it is plus 1 times 64 minus minus 56, and at the bottom it is 1 times minus 4 minus minus 4 minus 1 times 12 minus minus 3 plus 1 times 24 minus minus 6. So if we simplify, we will get minus 4 plus 4, which is 0, minus 32 plus 28, which is 60, plus 64 plus 56, which is 120. And at the bottom we have 0 minus 15 plus 30. So if we do the additions, we get 60 divided by 15, which is 4 for the value of x. So let's write it down here, x equals 4. By the way, the determinant of a is, let's write that too, because we don't need to calculate this all the time, it is 15. We'll keep this in mind too. Now let's calculate y. Now y is equal to the determinant which we change the second column with the results divided by the determinant of a. So if we do the calculations, we will have the following: 1 times this determinant minus 12 times this determinant plus 1 times this determinant divided by. So if we do the calculations, we will get 32 minus 28 minus 12 times 12 minus 3 plus 6 times 28 is 168 minus 48 divided by 15. And if we simplify, we have the following: 60 minus 180 plus 120 divided by 15. So this will give us 0 over 15, which is 0 for y. So let's record that too, y is 0. And now we will calculate z. So the calculation for z will be as follows: the determinant which we change the third column with the results divided by the determinant of a, which is 15. And if we write the calculations, we will have this calculation divided by 15. And if we calculate the determinants and have the multiplications, we will have minus 120 minus 120 plus 360 divided by 15, which will give us 120 divided by 15, which is 8 if we do the simplification. So we have z to be 8. So the idea of Cramer's rule is easy, just that the calculations are a little bit long. Now is your turn. Solve these systems of equations by using Cramer's rule and show me.